Dear students, today we are going to see about a linear programming model. How to form a linear programming problem we are going to see now. I'm Dr. C. Sudhakar with you. So let us see what are the basic terms in linear programming problems. So first one is objective function. Objective function means what is our total aim. So for example, linear function z equal to ax plus by, where a and b are constant, which has to be maximized or minimized, is called a linear objective function. So objective means what is our aim. So aim is to get the maximum or minimum. If you are talking in terms of a profit, the company should maximize the profit. If you are talking in terms of the expenditure of a company, you should minimize the expenditure of a company. Okay, so that is called the objective function. Maximize or minimize is called the objective. Decision variables. So to achieve this objective, to maximize or minimize, what are the factors we have to do? So in the objective function z equal to ax plus by, we call this x and y are decision variables. So with respect to what we are going to get the objective function. Okay, so in case of a profit means what is the product of the company. In case of an expenditure means on which you are going to spend. Okay, so that is called the decision variable. Okay, so what are the factors? X and y are the factors. So when you are making a decision problem or when you are making a linear programming model, very first thing is these two things we should know. What is the decision variable? Okay, that means based on which we will get the profit. So that we can assign some variables x and y. And finally we have to decide whether we are going to maximize this variable or we are going to minimize this variable. Okay, so both the things are called objective functions, maximize or minimize. It will change from problem to problem. Okay, constraints. So any linear programming problem will have some constraints. So what are the conditions? The linear inequalities or restrictions on the variables of a linear programming problem are called constraints. Usually they will be written as greater than or equal to or less than or equal to or sometimes like equal to also. Okay, so the conditions based on which the objective function will act is called constraints. Okay, what are the conditions we are having it? So particularly x greater than or equal to 0, y greater than or equal to 0 are called non-negative constraints. In case of a manufacturing unit, so if there is something manufactured, then we can talk about the profit or loss. So if there is no manufacturing, no people, no time means, so that means it is absolutely no work is going on. So therefore in most of the linear programming models, this non-negative constraints plays a very important role. So what are the conditions? Resource constraints, time conditions. So they will be having less than or equal to, greater than or equal to symbols. Non-negative constraints will have always greater than or equal to 0. So these are the very basic three terms in any linear programming model. So linear programming problem means linear programming problem is one that is concerned with finding the optimal value. It can be maximize or minimize of a linear function of several variables x and y. So particularly here we have taken only two variables. It can be 100 of variables x1, x2, x3, x4 like that. Okay, so based on these variables and based on the conditions and based on the non-negative constraints, what is the objective value or optimal value? So that is called a linear programming model. The term linear means it is of order a degree 1. Okay, so the term linear implies that all the mathematical relations used in the problem are linear, that is of power 1. while the term programming refers to the method of determining a particular program or plan of action. So linear programming models. Constraints are the conditions. Basically they will be, initially we are going to discuss about the linear inequalities, that is of each and every variable will be having the power 1, x power 1, y power 1, like that. Okay, so these are the basic terms. Repeatedly we are going to use it in the next classes, so you should be familiar about that. Linear programming problem, linear models, constraints, non-negative restrictions or constraints. Okay, so what are the steps involved in that? First step is we should first decide what are the decision variables. Okay, so identify the unknown decision variables to determine and assign symbols for them. Okay, it can be x, y, z or x1, x2, x3, x4, like that. First to decide what are the unknown decision variables. Okay, so what finally we are going to find it. Okay, so find out the factor and give some variables for that. In terms of a manufacturing means what you are going to manufacture. So we are going to manufacture 3 types of chocolates. So we can say type 1 chocolate is x, type 2 chocolate is y, type 3 chocolate is z, like that you can use. So since we are going to use many variables, it is always comfortable to use x1, x2, x3, x4 because we can extend it. Second thing is identify all the restrictions. Okay, so what are the conditions? So how many resources, how many hours the machine will work, and how many peoples will be working, how much production will be possible, so how much the market demand will be. Okay, so find out all the possible situations and you can convert them into conditions or constraints. Check which are the variables coming under the non-negative constraints. Most of the functions will be coming under non-negative constraints. Then finally check about what is the objective function. Finally what we are going to do with these variables, we are going to find the maximum value or minimum value, decide on that. So these are the 3 very important steps in any mathematical formulation problems, linear programming problems. Now let us take a question and let us see how to apply that. A mobile dealer deals in only 2 items, Samsung and Nokia. He has 50,000 OMR to invest. A Samsung mobile cost OMR 250 and a Nokia cost OMR 150. He estimates from the sale of one Samsung mobile he made a profit of 25 reals, and from Nokia he make a profit of 15 reals. The Samsung phone occupies more space, twice as Nokia phone occupies. His shop has display space of at most 3000 Samsung pieces. He wants to know how many Samsung and Nokia phones he should buy from the available money so as to maximize his profit, assuming that he can sell all the items which he buys. Formulated as a linear programming problem. Okay, it is just a formulation. We are going to convert this into a problem. That's it. We are not going to find the solution for it. Formulate it as a linear programming problem. So in any problems, first we should list out the data in a tabular form. That will be more convenient for us. Okay, so what are the things available? He is having 50,000 reals totally to invest. He is going to sell 2 mobiles, Samsung and Nokia. He has to buy it from the company, 250 real for one Samsung mobile and 150 real for one Nokia mobile. When he is selling to a customer, when he is selling Samsung mobile, he get a profit of 25 real, and when he is selling a Nokia mobile, he gets a profit of 15 real. Okay, and when you are keeping it in the display or the showcase, Samsung mobiles are bigger, so it is taking double the space as Nokia phones. Okay, so these are the conditions given to us. So finally what we want to know, we want to maximize the profit. Let us tabulate them. Okay, the tabular value is Samsung mobile cost 250 and Nokia cost 150. Profit from Samsung is 25, profit from Nokia is 15, and then space required is, if you keep one Nokia phone in the same space, double the space required for Samsung. Okay, so one small box is Nokia means if you are keeping two same, you can place one Samsung phone. Okay, so double the space as Nokia phone. So these are the given constraints to us. So let us, our aim is to know how many Samsung phone we have to buy and how many Nokia phone we have to buy. So let us give some name for them. Okay, so X is the number of Samsung phones we want to buy and Y is the number of Nokia phones we have to buy. It is a number of pieces. Okay, now let us formulate it one by one. So first let us see X be the number of Samsung phones and Y be the number of Nokia phones. Okay, let us write it very clearly. What is the variable meaning? Okay, it is very important for us because the reader should be given a clear information what is X and what is Y. Okay, very first step. Second step is let us write what is the non-negative constraint. Naturally we want to buy some phones and we want to sell some phones, therefore these two will be non-zero. X greater than or equal to 0, Y greater than or equal to 0. So we have written one non-negative constraint. Next let us come to the cost. So if you are buying X Samsung phones, we have to spend 250 into X. Okay, one Samsung phone 250 real and two Samsung phone means 250 into 2. So if you are buying X Samsung phones, it is 250 into X. Similarly, if you are buying one Nokia phone, it is 150 real. If you are buying two phones, 150 into 2. So if you are buying Y phones, 150 into Y. So he is buying X Samsung phones, Y number of Nokia phones. So 250 into X plus 150 into Y. So but he is having the maximum money of 50,000 reals. This is given to us in the question. So this is called the condition. So we cannot spend as much money as it is required. Whatever the money the investor is having, only that much we can spend. We can spend little bit lesser than 45,000, 49,000. That's not a problem. But we cannot invest more than 50,000. So we put it is less than or equal to. Please understand that is the meaning for less than or equal to. We cannot spend more than 50,000. If you go to a shop, if you are having 50,000 reals, you cannot spend more than 50,000 real, but we can spend less than that. So he can buy this much less than or equal to 50,000. This is called investment constraint. Now there is a common factor 250, you can divide by 50, 50, 50. So if there is a common factor available, you can divide the equation completely. Okay, when you are dividing, you should divide both the sides. So that was simplified into 5x plus 3y less than or equal to 1000. Now we finish the cost. Now let us come to the profit. So the profit is the objective function for us, okay, because that is the aim of the company. Let us finish this constraint. So Samsung phones and Nokia phones, how much space is required? Samsung phone occupies double the space as Nokia phone. So therefore we will write it as 2x plus y less than or equal to 6,000. For example, if you are keeping only Samsung phones, it will occupy 3,000 phones. So 2x should be less than or equal to 6,000. If you are keeping Samsung Nokia phones, it is 6,000 it will occupy. So the total space should be less than or equal to, because this is the maximum available space. So 2x plus y less than or equal to, since they are given the space in terms of Samsung phone, we just multiply by the space 3000 into 2, it is coming 6000 here. Okay, so 2x plus y less than or equal to 6000. that is a storage constraint. So we listed all the constraints: non-negative constraint, investment constraint, space constraint. Now let us come to the objective function. So we bought X Samsung phones, Y Nokia phones. If you are selling all of them, we get 25 real from Samsung phone each and 15 from each Nokia phone. So 25 into X, this is the profit from the Samsung phone. 15Y, this is the profit from Nokia phone. So the total profit of the company is 25X plus 15Y. So this should be maximized. So z equal to 25x plus 15y. Whether they are giving it or not in the question, by reading the question you must be able to guess the question is maximization or minimization. That is very important in any linear programming problem. Okay, so here we had to maximize the profit because it is in terms of profit of per piece. So therefore maximize are equal to 25x plus 15y. So let us make them the neat question. So first let us write what is objective function. Maximize z equal to 25x plus 15y. So then what is the constraints? 5x plus 3y less than or equal to 1000. This is space investment constraint. 2x plus y less than or equal to 6000. This is space constraint. This is non-negative constraint. The first one we call it as the objective function. That is the aim of the company. The second two are called the constraints, general constraints. The third one is called the non-negative constraint. So the given situation was completely converted into a mathematical equation which is linear. So this is the required linear programming problem. Okay, so hope you understood that. Let us do some more questions in the next classes.